We would like to try to reduce the heating of the buildings, and therefore we have looked into the nature like a source of bio-inspiration for the development of new technologies. In nature there are some biological systems like the pine cones that have an autonomous responsiveness to the weathering, in particular to the relative humidity. And we would like to use this autonomous responsiveness for the development of autonomous shading system. The pine cones are a biological system that goes from a flat configuration to a band configuration with the decreasing of the relative humidity. This is because during the day there is a regular change of the relative humidity that goes from higher value during the morning and the evening to lower value during the noon and the first part of the afternoon. We have implemented this principle into wood and bilayer structures, which are made by two wood species, and they are glued together with two different fiber orientation, and in response to the change of the relative humidity as the pine cones go from a flat to a band configuration. The challenges of the project are two. On one side, there is the upscaling, since we have to develop a lamella with a suitable dimension for a shading system, and the deformation of the wood is normally unpredictable. And on the other side, we have to develop something that has enough speed to be competitive to the other shading systems that are actually motorized and energy-driven. Since we want to develop a shading lamella, so we want to have certain dimension, I have worked on the modification of the surface in order to have a faster desorption of the water from the wood to the environment. And of course, on the other side, since we want to be competitive to the motorized shading system, I have also developed a couple shading solution, which is made by the combination of two elements, one active bilayer, that is the active element, and one passive element, which is completely driven by the bending of the active element.